My guest again today is Ian Plimer.
It's been an extraordinarily busy year, both with work and with public speaking and doing podcasts. Things haven't changed very much in this country as they have in the US, but in this country we still have an extreme left-wing government, which is very much sending us broke with their climate policies. Their energy policies are just absolutely ridiculous. Here we are, a country blessed with a huge amount of energy, blessed with a huge amount of uranium, thousands of years of gas, thousands of years of coal, and yet our energy prices have gone through the roof, and there's a scarcity of gas. You know, that can only be mismanagement. It cannot be anything else. So we've had, in my view, a disastrous year here in Australia because of very poor government policy, and government's trying to appeal to a very, very small minority of people who've got no skin in the game. So that's what's new. I'm still disappointed at the way that this country's going. I'm very pleased the way some countries are going. I think Germany's finally realised the folly of their climate policies. The US has well and truly changed. They're an energy exporter, as we are in Australia, but the energy in the US is very cheap. Other countries are starting to wake up, but some countries like the UK still have very, very expensive energy. So nothing much is new. It's the same old, but it's getting worse.
So last time we talked, you were just going to head to the U.S. I think in January of this year, you were heading to the U.S. How did that trip go?
Well, I went to the Trump inauguration. It was some of the coldest weather I've ever had in Washington at that period of time. And after various functions and parties, etc. And one of the balls I went to, one of the three balls that Trump went to the same evening, I don't know how he's got the stamina to do it. I went and warmed up in Florida and then came back to Australia. So that was my January last year. January this year is a little bit less exciting. I'm off to Saudi in a couple of weeks' time, going to a conference and then doing some geological field work down near the Yemeni border. So that'll be my January this year.
Do you plan to come to the U.S. for the Heartland Conference in April?
I have a clash in my timetable on that one. I had a class also for the CPAC conference, which I intended to come to. I've only ever been to one Heartland conference, and that was years and years ago. I've been to a number of CPAC conferences here in Australia, but not in the US. So again, I have an absolutely full diary, and when people are asking me now for my time, I have to say, no, the diary is already full for 2006. It's just crazy.
So I've been reading your new book, Sceptical Always, and I was saying before we hit record, I love this book. It talks about so much stuff you've done in your life. You have had such an interesting life, and the whole book is essays from you, correct?
Oh, yes. Yes, it's a collection of essays, some of which are long, some of which are shorter, some of which have been previously published in The Spectator, some haven't, and they deal with a huge diversity of subjects, of areas that have interested me over my life. And I've been very fortunate where I've done field work in all sorts of parts of the world, and even more so, someone else has paid for it. Currently, I'm doing a lot of field work in South America and in Saudi Arabia. There are no stories of those parts of the world in the book, but some areas of Australia, a number of places in Turkey. I describe some of the experiences I've had there. One of the experiences I described in Iran, where I was kidnapped by the Mujahideen, and it took me a while to realise that I wasn't worth any money, that they were actually after my services as a geological consultant to help these ultra-poor people find the minerals, exploit them. That was an interesting phase of life. I've described children that I met in Turkey. That was quite... well, they're my best stories. I think they're fairly passionate, but they're about these kids who are just really born into absolute poverty, into a culture that is pretty brutal. Stories about how I was a survivor in a jet aeroplane that crashed. Stories of my views on creationism, on climate, on environmentalism. It's an eclectic bunch of short stories, and essays such that you can read one and you'll be almost asleep. You put it down and you're asleep. So there's 50 of them. It's not a hugely voluminous book, but there's 50 of these stories written about various things I've done in my life. And it's been a very rich life. And I think the title I used, the subtitle of A View at Three-Quarter Time, I think that's what it was. Yes, A View at Three-Quarter Time. Yeah, that's a bit generous. At three-quarter time, if I go the full 4 quarters, that puts me over 100 when I shuffle off. So that's a bit optimistic.
Yeah, I think it was just a great idea to put all this stuff together. I see your first essay here is from 1971, and it goes all the way up to 2025. And you got tons of climate change stuff in there as early as maybe 2006 or 7, I think, or probably before that even. So yeah, a lot of the stuff that you wrote about climate close to 20 years ago is is great to read even today. It stands up totally.
Well, the science that I use in those climate change articles is geology. The geology has become refined, but what it's meant is that the scare campaigns, which I think are the biggest fraud we've ever seen on planet Earth, the scare campaigns have got shriller, but the science has also become more refined and shown that climate change is just a load of baloney. So I was onto this in the 90s. One of the books I put out, A Short History of Planet Earth, described the current fad of climate change. And so I've been writing about this for a long time, and all that's happened is the climate change arguments have been dismissed and dismissed and dismissed. But those promoting them have never been accepted. They just haven't accepted that the arguments are fallacious. Why? Because it's a great new business, a good new business of frightening people witless and making money out of something where money should not be made.
Yeah, I don't think it's possible for someone to read your climate change essays in this book with an open mind and still think that climate is so simple that CO2 is the climate control knob, because you absolutely rip apart that argument over and over. I love it.
Well, yes, the argument I use is mainly from geological reasons. For example, we had periods of time in the geological past when the atmospheric carbon dioxide content was above 20%. Now, what that means is, using a popular thinking, is we should have had runaway global warming. We didn't. We had the biggest ice ages this planet's ever seen, with kilometres of ice at the equator and at sea level. And then the counter argument is, oh, well, we had booming microorganisms then, and they were changing the carbon dioxide balance. Well, that's not true, because these microorganisms have very short lives. They die, and they end up giving us carbon-rich sediments, mainly fine-grained sediments, scaly rocks. They tend to be black. Now, in these ancient rocks, we don't find black shales. So that argument doesn't fit with the data. So they cannot argue against the validated geology. And time again, they bring up fallacious arguments to try to knock it out of the court, but it doesn't work. The data's not there. So I use data, I don't use opinion. And as a result of that data, I've come to a conclusion. If I have new data, I'll change my conclusion.
One thing that I really enjoyed, as I read through these essays, I underlined a lot of stuff. And I do plan to put a lot of quotes on Twitter, just one quote at a time, because there's so many individual quotes that are just fantastic. But you're talking about sea level rise and some drilling that was done to see whether coral atolls grow. And I think you said that they drilled down 928 feet and the coral went down that far at some point.
Yes, there was an idea that we hear from our climate people that because it's warmer, we're going to get a sea level rise and we're going to inundate the coral reefs, especially Pacific atoll island nations. And these people promoting those ideas have no idea of history. We have writings by Charles Lyell in 1830 to 1833, where he put out the textbook of geology. And in that textbook, he argued that these coral atolls in the Pacific formed from volcanoes which were sticking above the ground or above the water, and they slowly sank, and coral started to grow on them and kept growing as the volcanoes sank. Now, that idea really appealed to Charles Darwin, who went and inspected many of these coral atolls in the Pacific, and he came to the same conclusion. And actually, Darwin put out a book in 1842 about coral atolls. These people trying to frighten us witless should look at the literature of the past, and that shows that they're wrong. And that idea also fascinated the professor of geology at Sydney University, Professor Sir Edgeworth David, and he persuaded the New South Wales state government to fund drilling of one of these coral atolls in the Pacific. And these drill holes went through over 900 feet of coral and didn't hit the volcanic cone that was meant to be sinking. Now, that proved that clearly when sea level was changing, we had the coral growing, and also proved that the volcano must have kept sinking. And it wasn't until we had the atomic bomb tests in the Pacific where various coral atolls were drilled by the Americans and by the French. And some of these drill holes went down kilometres before they actually hit the basalt volcano. It went through kilometres of coral. So clearly, when sea level rises, which is in effect when a volcano is sinking, the coral loves it. And it not only grows upwards, it grows outwards. Now, we've got more recent information from satellite measurements of both the Indian Ocean and the Pacific Ocean showing that we have got our coral atoll masses actually growing in size. And they are growing in size both upwards and outwards. There are a few exceptions. There's only a few. And most of these exceptions are where the coral has been quarried for road base, for building materials, for the base of airports, and for making cement. But in effect, if sea level rises, the coral loves it. If it warms up, the coral loves it. Many of the Pacific atoll corals are cool water corals, such as those of the Great Barrier Reef, compared with those in the Red Sea, which are much warmer water corals. So coral loves it warm, it loves sea level rising, and what we're being told has been demonstrated to be wrong, and we've known that for more than 150 years. So the whole argument about sea level rise is fallacious. We know that sea level rises and falls. And there was a gentleman that worked for Exxon, Peter Vail, who published a sequence of Vail curves. Peter Vail has just recently died, but his Vail sea level curves show that over the last 20% of time, sea level has been anything from 200 to 300 metres higher than now on average. Sea level goes up and down enormously, and we're living in times when it's very benign, when sea level is relatively low. So we've got a huge amount of evidence from oil exploration, from coal exploration, from academic studies of coral reefs, from drilling of coral reefs, from satellite imagery of coral reefs, that the story we're being told is demonstrably wrong. There's absolutely no scope for argument. Now, I cannot see why this is not accepted by the climate catastrophists. And the only reason they can't accept it is that this is a business where they're making money out of frightening you witless and having you, the taxpayer, pay up for some harebrained scheme to try to stop sea level change. They should actually go to the Bible and see how it's impossible to actually stop sea level changes or sea level rise. We've known this for such a long period of time, and this whole climate catastrophist view of the Earth is one that you can only hold if you ignore the past.
So I think you've said that even in the last 10,000 years, there's been times when sea level's been a couple meters maybe higher than now, correct?
Yes, we came out of the last ice age, the last glaciation. We came out of that 14,400 years ago, and sea level started to rise, and it got to a maximum about 8,500 to 4,500 years ago. It was also a few degrees warmer than now, and since then, sea level has been falling. Now, you see this in many coastal areas. At the base of a cliff, you'll see a little nick where the waves 4,000 years ago had eroded the base of the cliff when sea level was higher. So we see that as global evidence of sea level change. We also see global evidence of land level rise and fall. For example, Holland is sinking, Scotland and Ireland are rising. We have land level rises and falls all the time. We see in Scandinavia, we've had a rise of a rise of the land level of about 340 metres over the last 14,000 years. Now, that's because the land was depressed when it had a few kilometres of ice on it. The ice is now gone, so the land is rising. Rocks are slightly plastic, and you load them up and they will bend. You load them up over a very short period of time and they will break, giving you an earthquake. So we know from history the biblical city of Ephesus was a port city. I've been there. It's now inland and above sea level. We know from history the city of Lydia, where gold coins were first minted. That city was a coastal city. I've been down the main street in a yacht. The main street is a few metres below sea level, and you can actually sail over it and see the main street. So the whole concept of sea level rises and falls in recent times is fallacious. Again, you've only got to look at history or look at geology, and you can see that in such a short period of time, we've had sea level and land level rises far greater than the scariest scenario that's being painted at present.
So you mentioned that maybe in the last 10,000 years, the Earth has been a few degrees centigrade warmer than now. Is that correct?
Yes. During the Holocene optimum, it was probably about 4 or 5 degrees Celsius warmer. And then it started to cool down with warming spikes in Minoan times, in Greek and Roman times, and then medieval times, and now in modern times. So we're on a long-term cooling trend, and we've been cooling for about 50 million years. The latest significant cycle of cooling started about 4,000 years ago. So we have long-term trends. Within those long-term trends are short-term spikes. And the real question we have to ask is, well, if we had a warming in Minoan times, if we had a warming in Roman and Greek times, if we had a warming in medieval times, and now we have a modern warming, which part of this modern warming is due to human activity and which part is natural? And it's never been demonstrated that the modern warming is of human cause. It's been argued that the slight warming we've had since the Little Ice Age is of human origin, but it's never been shown. And I think if you look back in time, you'd have to say, well, it looks very natural to me. The lengths of warming and the intensity of the warming is not nearly as great as previous interglacial warmings. So the answer is, well, it's probably natural.
So if I wrote this down correctly, you estimated that it might have been 23 years between the medieval warm period and the Little Ice Age, that there was quite a quick switch there?
Yes, the switch was in 1280. It was warm. We were having 2 crops a year in Europe. There was so much excess wealth generated from these crops that we built our great monasteries and cathedrals and universities. And then 23 years later, the Gulf of Bothnia, which is that water mass between Finland and Sweden, the Gulf of Bothnia froze, and it froze year after year after year. So it took 23 years to come out of a warming into a cooling. That's the rate of change that we see naturally. So if we cannot, over the last 40 years, see any change due to human activity, and that 40 years is when we've had satellite measurements and balloon measurements, then what are the chances of the modern warming being unrelated to human activity? And I'd say very high.
All right, I'm going to jump around a little bit here, but in one of your other essays, you mentioned that dinosaurs may have developed special eyes because they had to live in the dark, maybe near Antarctica. That sound right?
We have fossil evidence from rocks that formed close to Antarctica. They've now drifted away. We had fossil evidence that the dinosaurs had very large eyes. And the conclusion based on that is, well, okay, we were in Antarctica. We had long seasons when it was dark and long seasons when it was light. And the large eyes were needed in these periods of darkness. By the way, Antarctica then had a temperate climate up in the mountains. We had some snow and we had some glaciers and some ice. We see evidence of material that's been glaciers that have shifted down the slopes, carved, gone out to sea and dropped any boulders that are in them. We've got evidence of that from that period of time. So we can integrate many areas of science, such as paleontology, such as glaciology, such as geology, and come up with a valid story. The climate scientists don't do this. They use mathematical models, and that's it. And these models predict the future, none of which will work, of course. But in geology, we integrate large areas of many disciplines, and most geologists are polymaths. We have a knowledge in many different areas. So yes, we did have at a time dinosaurs that had very large eyes. These dinosaurs lived in Antarctica. This was about 40 million years, 50 million years before their extinction. And they are preserved as fossils. That's pretty good evidence, I think.
So any ideas how they could survive those long periods without lights if the plants probably weren't growing during that time either?
Well, they probably were like many animals that live in high latitude areas, that they hibernate.
That was my guess too. Interesting.
Mm.
One other thing that you mentioned in the last time we talked is you were hoping to meet Nir Shaviv to learn more about what his work is about. Did you do that, or have you looked into them?
I still haven't met him, and I have every intention of going to Israel to meet him. I see his name on various conferences. I write various book chapters, and he's an author. There's a chapter I just sent off on Christmas Eve. I know he's an author in that chapter, but he's an isotope chemist looking at the stable isotopes, and these are the isotopes of hydrogen and oxygen that he's looking at, also sulfur and other isotopes. And from that, you can calculate all sorts of interesting things. You can calculate what the temperature was. You can calculate the ancient latitudes. I was hoping to meet him at the Hebrew University of Jerusalem, but it's been difficult to go to Israel. I tried to go there once earlier this year, but we were flying in a private plane, and because it was the same make and model as Israeli spotter planes, we were advised not to come into Israel. So instead we went to the Seychelles, which in themselves are very interesting. The Seychelles are a little piece of granite sitting out in the Indian Ocean, and they shouldn't be there. Islands out in the middle of the oceans are pieces of basalt from basalt volcanoes. And this piece of granite comes from Western India, and it's moved right down off the coast of Madagascar. And this was some of the geology that was used in the early 20th century to work out that, in fact, we've had continents break up and continents drift. And this was the work of the glaciologist Alfred Wegener. He was pilloried for his ideas, but later, of course, it was shown to be correct. So I was very happy to be diverted to the Seychelles and have a look at these granites.
One other thing you mentioned multiple times in the book is that the possibility that El Niños are kicked off by submarine volcanic activity. Do you have any more thoughts on that?
This comes from the work of Wis Yim from Hong Kong. And he's been working on volcanoes for decades. And he's also trained in mathematics. And he's been looking at the mathematical relationship between swarms of earthquakes in the mid-ocean ridges, which you can measure by seismic activity, and those swarms of activity of earthquakes then has a big El Nino afterwards. And the only reason you get swarms of earthquakes is that you've got molten rock that's moving up and pushing aside the rocks around them and breaking them and giving you earthquakes. That molten rock comes to the surface. When it comes to the surface, it's about 1100 degrees Celsius. It's a basalt melt, and that is cooled by bottom waters at 2 degrees Celsius. So you're transferring heat from a molten rock, and it cools into the ocean waters. Those ocean waters rise, and that patch of warm water at the surface is the oceanographic feature that drives El Niños. So his thesis is that these El Niños are probably related to volcanic activity and probably not related to unusual meteorological effects where suddenly you have a a pool of warm water in the ocean. Now, there isn't enough data. I rather like the idea because it fits in with a lot that we already know. However, if you're a climate catastrophist, you don't look at what volcanologists tell you. You look at what the mathematical models tell you, and it's no wonder you come up with the wrong answer. So these are quite fascinating meteorological phenomena. We don't know enough about them. We don't have enough measuring stations on the floor of the ocean, but we can do mass balance calculations. So if we have a cubic kilometre of basalt, molten basalt that goes onto the sea floor at 1100 degrees Celsius, that puts enough energy into the ocean to drive 30 major hurricanes. So there is an energy transfer and there's a heat transfer. There's not enough done on this, but it's a fascinating idea.
And I don't have it in front of me, but in the book you list or you say that there are just way more undersea volcanoes than above ground volcanoes on Earth, right? By a huge factor?
Well, we have about 1,800 volcanoes on the surface, and these we measure. These are close to civilization. We've currently got Mount Etna erupting. That, if it was a major eruption, you could have millions of people killed. So we monitor those very, very carefully. I've been in Indonesia when we've had an eruption. These are monitored, and they're monitored by measuring the slope of the ground, measuring the seismic activity, measuring the gases coming out of fractures, measuring temperatures, and many, many things. And we're getting fairly good at predicting when we're going to have a major volcanic eruption, not a minor one, but a major one. And that's because we've monitored the 1,800 surface volcanoes very well. But on the ocean floor, we're pulling apart the ocean floor, and we have nearly 70,000 kilometres of mid-ocean ridges. And along those mid-ocean ridges, we have volcanicity all the way along them. Then off the ridges, we have got a measurement of over 3.4 million volcanoes, which are active or extinct, that are sticking above the sea floor. Now, these must have transferred heat, and they must have transferred energy, and they must have transferred carbon dioxide to the seawater. They're never taken into consideration for any of the models. And the Earth has been cooling down for 4,567 million years. It is still cooling down. Most of the Earth's surface is the ocean. The thinnest crust is the oceanic crust. This is where most of the heat goes as we're cooling down the Earth. So we're adding heat, carbon dioxide and energy to the oceans over time. That's never taken into consideration. And sometimes when geologists look at it, they will give a figure of anything from 3% or above, but we really don't know. We don't know how much heat is going into the oceans. So there's heat that's coming from above, and that's from the sun, and there's heat that's coming from below, and that's the cooling Earth. And that cooling process is spread out because we have the natural decay of radioactive potassium, uranium, and thorium deep in the Earth. This gives out heat. So there is another source of heat that may well have an influence. I'm not saying it drives it, but it may well have an influence in climate. And that is the cooling of the Earth, especially in oceanic areas, especially from the very, very large number of volcanoes. Now, we monitor 1,800 surface volcanoes. We don't monitor any submarine volcano. So we probably know more about the moon than we know about the ocean floor.
So yet another fascinating thing in the book is that you talk about so many civilization-changing volcanoes in the past, the details of those. You said that we have good monitoring, at least of many of the above-ground volcanoes, so we'll get some warning if Yellowstone, for example, is about to blow. But there could be something brewing in the ocean that we don't know about, and we could be surprised at any moment. Is that true?
Well, the oceanic volcanoes tend not to be explosive. There have been one or two in the Arctic that have been explosive, but they're not massive explosive volcanoes. It's a different sort of melt composition to those in continental areas. In continental areas, we have rocks which are much richer in silica and aluminium, whereas in the ocean, these tend to be more magnesium and iron rich. So our oceanic volcanoes are not explosive. Our terrestrial volcanoes are. And we have volcanoes which will explode, like Krakatoa in 1883, and that pummeled 30 cubic kilometres of rock into fine particles. That dust surrounds the planet. That dust reflects light and heat, and we cool down. We had the 1815 volcano of Tambora in Indonesia, and that was called the year without the summer. That was an equatorial volcano. We filled both hemispheres with dust, and that 30 cubic kilometres of dust in the atmosphere reflected light and heat. But we then have supervolcanoes, and these are in Kamchatka, these are in Yellowstone National Park, Taupo in New Zealand, some in Chile. And these supervolcanoes will blast out anything up to 10,000 cubic kilometres of rock into the atmosphere, which is pummeled up into fine dust. Now, these supervolcanoes we've had before, and we'll have them again. And we had the supervolcano about 70,000 years ago of Toba in Indonesia. And that put so much dust into the atmosphere that we had a long period of cooling within already a natural cooling period related to the Earth's orbit. And that, I suspect, has led to the extinction of 3 of the 4 species of humans that existed on Earth. We humans very nearly became extinct. We went down to 4,000 breeding pairs. So a supervolcano can have a massive effect. It can kill off populations. Now, imagine if you had a supervolcano in Japan or in Yellowstone National Park. You would actually have a strain on the US economy. You would have strain on agriculture in the Northern Hemisphere. It would be massive. If you had an Indonesian volcano or a supervolcano, and we've had them before, the dust would fill both hemispheres. And so you'd have the whole Earth under strain. The Chilean volcanoes, we know full well that they're the ones that give the massive tsunamis in Japan. They're the ones that have blanketed much of the Andes with thick layers of volcanic dust. So supervolcanoes could easily wipe out a population. We know that a normal volcano, like in Santorini, about 1600 years BC, Santorini was nothing special, was nothing huge, but it just happened to be at the centre of the population. In those days, it was the Minoan population, which was in North Egypt, Lebanon, Western Turkey, Greece, and the Greek islands. And the Santorini volcano, and some of you people watching this have probably been to Santorini. It's a great tourist island to go to. Santorini erupted, put a lot of dust into the atmosphere. There were tsunamis. Tsunamis were probably 300 metres high because there's evidence of seafloor rocks on top of fairly high hills on the island of Milos, which is an adjacent island. And I worked on Milos for many years. So Santorini wiped out the Minoan population. It wiped out the dominant empire, and that led to the rise of the Mycenaeans, which led to the rise of the Athenians. So that one volcano changed the whole course of Western civilization. It could happen again. We could have a major volcano change the course of Western civilization. A supervolcano. Santorini wasn't a supervolcano. It was just a normal large volcanic eruption pumping out 30 cubic kilometres of rock that's ground into dust. So one volcano can ruin your whole day. One volcano can change the course of history. It's not the submarine volcanoes we have to worry about. It's the terrestrial volcanoes. And this is why we monitor them.
Okay, and then there are many different dangers that those huge volcanoes cause, right? That you mentioned the 300-meter tsunamis, or people just getting covered with the dust. Or did you say also that there could be sharp shards of dust in the air that if you breathe it, it'll damage your lungs also, right?
Well, that's the main killer. Is sharp shards of the dust. This is glassy material. You breathe it in, it cuts your lungs, and you drown in your own blood. And the most common cause of death from a volcanic eruption is people drowning in their own blood, asphyxiating. That's extremely common. We have some evidence in Papua New Guinea of tribes getting such a fright they fell over a cliff. That's a rare way of dying. Tsunamis, of course, are very common. There are gases such as sulfurous gases, which can kill you and give you respiratory problems. That's a very common way of dying from volcanic eruptions. I suggest if you live on or near a volcano, you should move. And there are plenty of people in Central America, in Washington State, in the US, in Japan, in North Island and New Zealand and other places that actually live on volcanoes. Maybe it's time to move.
I'm curious how often in human history we've had a year without a summer caused by volcanoes, maybe, and what we would do in modern times if we tried to feed 8 billion people if we had another one of those.
We've had it many times in the past, and we've had depopulation during those times. To feed 8 billion people, if it hit the food exporting areas like the US, there would be trouble. But the food importing areas like the Middle East, they're the ones who may well end up not having food because there wouldn't be excess food produced in the food exporting countries. So I think there would be depopulation if it was a supervolcano. We've seen it before, and we'll probably see it again, but we're better prepared for it. In former times, we didn't have international trade. In former times, we couldn't take shiploads of food from one country to another. It will be difficult to do it by aeroplane. We have very good records of aeroplanes having all sorts of troubles when they're going through a volcanic ash cloud. There's a good example of a British Airways flight coming over Indonesia where all 4 engines clogged up with volcanic ash. This volcanic ash froze onto the blades, and the pilots must have had nerves of steel, but they dropped altitude and eventually were able to start the engines and land the plane. But the windscreen was absolutely blasted. It was opaque because of the fine particulate dust. And now whenever there's a volcanic eruption, there's an aircraft alert and planes are diverted around the cloud because we've had experience before of this ash hitting hot turbines, melting and then freezing and stopping the turbine blades. So we probably couldn't use aeroplanes for rescue and for transport of food, but we can certainly use ships.
So it sounds like that year without a summer wouldn't necessarily mean that you couldn't grow food anywhere on Earth. Maybe you still could grow food somewhere.
You still could grow, but you would struggle and you wouldn't produce the amount of food you normally produce. So people would struggle. Now, in a country like this one in Australia, if we had a massive southern hemisphere volcano in New Zealand or in, say, Chile, by the time the dust did a lap of the planet, it came over Africa and came to us, much of that dust would have gone. We would be in a better situation. We don't have any active volcanoes in this country, but it's the northern hemisphere where you have the bulk of the world's population. It's the northern hemisphere that would really suffer if we had a northern hemisphere supervolcano erupt, or even one in Indonesia or Central America, an equatorial volcano.
So one more unrelated question on disaster scenarios. How about the risk of a Carrington event happening again and possibly knocking out our electronics? Is that something you think about or worry about very much?
Well, I don't worry about volcanic eruptions. I don't worry about Carrington events because there's nothing I can do about it. But a Carrington event was where we had a burst coming out from the sun, and I think it was 1859, and we filled the cables where people were sending telegrams. We filled them with electrons, and there was someone in Canada who was a telegraph centre operator who was actually electrocuted and killed. Now, a Carrington event is where we get a great burst of electrons coming out of the sun. Carrington event would knock out satellites. A Carrington event would therefore knock out our mobile phones. A Carrington event would therefore knock out most electronic systems on the planet, and we would go back 100 years or so. We might even end up, instead of walking around the street looking into a mobile phone screen, we might end up talking to each other. But the chances of a Carrington event happening again are very high. They will happen. There's nothing we can do about it. We get bursts of energy coming out from the sun, which we can measure. But if one of them is focused and aimed at planet Earth, we have a problem. We would end up with no satellites. We would probably end up not being able to do something like this program, which probably, well, I'm using Starlink, so that goes through a satellite. It would change the Earth enormously. It would push it back hundreds of years in some parts of the world, and in other parts of the world, maybe a century. We'd all be equal. We'd all be struggling, but we'd all be equal. There'd be no technological advantage.
All right, switching gears again. So many interesting things in your book, unrelated to climate. You mentioned that close to the Himalayas, a plumb bob was not vertical, and there's gravity from the Himalayas, maybe?
Well, this was the East India Company in the 19th century who employed a group of surveyors to survey their territory. And in all surveys, you close them off. You do a great circuit and you close it off. And it should be plus or minus an inch or so on a long survey, or plus or minus a quarter of an inch. Well, they couldn't do it. They just couldn't close off this survey. And then one of the surveyors realised that the only reason why this couldn't happen was that the plumb bob must not have been vertical, that the Himalayas must have had a gravitational effect on the plumb bob. And so a correction was put in for this, and it didn't quite work in closing the survey. And then it dawned on the surveyors that the Himalayas are not only sticking out of the ground, but they've got a root to them. And that root had a gravitational effect on the plumb bob. And when the amount of land sticking above the ground and the amount of land which was speculated was below the ground was computed, then the surveys could be closed off. So that's how we learned in the 19th century that mountains have roots. They just don't stick out of the ground. That there's a mountain rock below the ground as well as above the ground. And as the mountain rises, we keep lifting that mountain rock up to the surface. Now, we know that. We know from going to the top of Mount Everest that at the top of Mount Everest is a limestone. It's got fossils in it. Limestones with fossils in it formed in shallow water. So to push up material that great height means that we're pushing down material as well. And so that was the beginning of understanding of mountain building. That led to the understanding later of how we fold rocks and bend rocks and break rocks. And that later led in the 1960s to our understanding of plate tectonics. So most science is, it's not a eureka moment. We build great ideas on the shoulders of giants. And these were people working in steamy India, doing a survey, and it didn't work. And they were smart enough to ask the question, well, that's curious. I wonder why not. We did everything right. And they came up with the concept that mountains have roots and mountains have a gravitational effect. Now, we know that today. When we measure sea levels by satellites, we find that sea level near mountains, such as the sea off the Andes, is higher sea level than in the centre of the ocean because the mountains have gravitationally pulled the seawater towards them. So, again, if you talk about sea level, the sea's not level at all. And if you sail from Chile to the centre of the Pacific Ocean, you actually get downhill.
So do you think we can remove all the other land rising and all the other factors and figure out global sea level changes from year to year? Do you think we have the ability to do that now?
We can do it on a scale that Peter Vail did with the Exxon Vail curves. But we don't have enough data to work out what sea level's doing on such a detailed scale, nor do we have enough data to work out what the land level's doing. And you can't talk about sea level change unless you talk about land level change. We know that land level change very quickly. They've changed in historical times, they've changed in archaeological times, and they've changed in geological times. So any discussion of sea level without talking about land level is, I think, misleading and deceptive. So I don't think we're there yet, but this is the beauty of science. We are still evolving and we're still getting better measurement techniques and we're still refining all of our thinking.
Do you think the diameter of the Earth has been exactly the same for the last 100 million years or more?
No, not at all.
Changed.
The diameter of the Earth changes, and that changes the rotation of the Earth, which changes time and also changes the orbit of the Earth. And we see that the orbital cycles, which would change the diameter of the Earth. The other thing is that we get some planets sometimes get a bit closer to the Earth than they normally are. That will change the diameter of the Earth. The Earth is degassing over time, and it's degassing hydrogen and helium. It's also adding about 80,000 tonnes a year for extraterrestrial dust that's dropping onto the Earth. So the Earth's size is constantly changing, and its shape is constantly changing, but only very, very slightly.
So maybe along those same lines, you mentioned that gravestones may change shape over time.
Yes, when I was at the University of Melbourne, I used to sometimes go for a lunchtime walk through an adjacent graveyard. I don't know whether these were graves of failed students or prominent residents, but you would see 100-year-old gravestones were bent. And these were not made of granite, which many of the headstones are, or not made of diorite or basalt. They were made of marble. And clearly, if it had been bent over 100 years, then the rock must have flowed, and we know that. Some rocks, like marble, are very much like glass. If you suspend glass, say, between two chairs, over time, it will bend. So many solids actually, over time, behave like a liquid. That's called rigidity. Now, you get a solid like marble and hit it with a hammer, it'll break. So that's a force over a short period of time. If you have a force over a long period of time, like gravity, it'll bend. The same with glass. If you had hit glass with a hammer, it'll break. If you look at glass in old cathedrals, the window glass is thicker at the bottom than at the top. That's because the glass has flowed down due to gravity. So many substances behave as solids in some settings and as liquids as others. We know that because we can fold rocks. When we compress rocks, they bend. If you compress them over a short period of time, they will break. Now, we see folded rocks, bent rocks all over the planet. So rocks, under certain conditions, when they're warm and when they're under pressure, they will bend. Rocks under other conditions will break. The same with headstones. If you hit a marble headstone with a hammer, you'll break it. If you leave a marble headstone there for a long period of time, it will bend.
So are there any lessons there for how glaciers move? Or I'm particularly interested in Otzi, the Iceman. What do you think actually happened to him? I don't know if he moved a lot underneath the glacier or what happened there.
Well, that's a very perceptive two questions you've asked. The first, we know from glaciers that the size of the ice crystals at the head of the glacier, at the beginning of the glacier, are very, very small. And the ice moves by recrystallizing, and the crystals get bigger and bigger and bigger. And at the toe of the glacier, you have big crystals of ice. So that glacier has flowed by recrystallization. We know that from rocks. We know it from metals, where we will anneal metals to make bigger crystals, and crystals that have got rid of impurities. So ice will move by recrystallization. And that's helped by the force that's on it, and that's the gravity. In a glacier, there's a slope. We know that in Europe, we have glaciers that have contracted and expanded. I've been to the emerald mines in Hubachtal in Austria. These were mines high up in the Alps where there were villages, and these villages were mining the emerald. And that area then had glaciation, and the ice expanded and covered the emerald mines and the villages. And then the glacier retreated, and because it retreated, I can now walk up to it and see it. So this is how we've found fossil humans who were able to traverse the Alps. They traversed the Alps when there was little or no ice there, and then the ice came and covered them, and then they were exposed when the ice retreated. Glaciers expand and glaciers retreat. Just because one glacier is expanding doesn't mean that we're cooling. Just because one glacier is retreating doesn't mean that we're warming. It's due to many, many other factors. So we see that. We see it from history. Hannibal was able to cross the Alps with elephants. You couldn't do that in times of say, the Little Ice Age. the ice sheets were much, much more extensive. So the ice sheets of the Alps we've known from 1,000 years of history, 2,000 years of history actually, that they expand and they contract. So it's no wonder we'll find human remains here. It's no wonder we'll find places where humans used to live that were covered by ice and now the ice has retreated. I think it's quite fascinating because it's in many ways driven where people live and what they do.
Okay, another thing unrelated that you mentioned is, do you think there has been life on Mars already? Do we have evidence of that?
There was a meteorite found in Antarctica that had the same chemical signature as the chemical signature that the Viking mission on Mars found. And the conclusion was that this is a Martian meteorite. Now, Antarctica is a happy hunting ground for meteorites because you've got a black meteorite sitting on the white ice, easy to see. And a meteorite was found in 1984, given the unforgettable name of ALH 84001. ALH is for the Allen Hills. 84 is the year it was found, 001, the first meteorite found. And it had the chemistry of Mars. And that was a fascinating find because it then led to the idea that Mars must have been impacted. Bits of Mars blasted out of the Martian gravitational field. It then got caught up in the Earth's gravitational field and fell to Earth. And, of course, the obvious thing to look at is what is the chemistry of the surface of Mars? It was predicted and it was shown to be correct that this Martian meteorite was the same chemistry that people had predicted for the surface of Mars, and this is a basaltic rock. It's similar to those we see on the ocean floors and the mid-ocean ridges. Now, those basaltic rocks reflect sunlight, and from that reflection, we're able to work out what the rock was. With ALH 84001, there were some detailed studies done, and it was then put away for a while, and then later people came to reinvestigate it and found tiny little bubble-type shapes there, and it was suggested these might have been chains of bacteria that were fossilized on the surface of Mars. And that idea was poo-pooed. The main reason for that was that these were too small, that we just don't have any terrestrial bacterial life of that size. And there was a lady in the University of Queensland in Brisbane who was doing some electron microscope work on chips of rock that had come up from oil drilling in the Timor Sea. And she was looking at how much these rocks had been cooked up and whether the oil window was reached. In other words, whether the oil had been cooked up and driven out of the rocks or whether any oil in those rocks would have remained. And she hit them with an electron beam in a vacuum at 25,000 volts, and these specimens heated up. Then she put them away, stored them in a vacuum, and a little while later she looked at them and things were growing out of these little chips. And she was curious enough to look at these under the electron microscope and saw that these were living bacteria. And these were the size of little chains of what was suggested to be bacteria from ALH 84001. And she came to the conclusion, well, you can have bacteria the size of that which is suggested for ALH 84001. And so the idea then floated around that maybe there was life on Mars, bacterial life. Some other people then did some stable isotope work on oxygen, hydrogen, and sulfur, and they suggested there might have been bacterial life on Mars. And then there was a more recent paper I read since I wrote that essay suggesting that no, these chemical signatures not that of life. And then something I read yesterday was suggesting that beneath the Martian surface is ice or solid water and then liquid water. And so once you've got liquid water, then the chances of you having bacterial life are very high. For example, the liquid water underneath the ice sheets in Antarctica has got bacteria in it. So we've come back again to the idea that there might be life on Mars. Now, we've certainly had water on Mars. We've got water-bearing minerals. We've got channels where water ran. We've got what used to be oceans on Mars. So I think the jury's still out whether we had life on Mars or not. But I think in the next 20 years or so, we will find bacterial life on Mars. It's just a matter of collecting the right samples from the right place. So it's quite fascinating. And this, of course, is going to be a major theological discovery that not all life was formed on Earth, maybe formed elsewhere. And it's a distinct possibility because the oceans, the original oceans in Mars are older than the original oceans on Earth. There's a distinct possibility that Earth could have been seeded by Martian bacterial life. So these are some of the great scientific revelations we're going to see in the next phase of Martian exploration. So watch this spot. It's pretty interesting.
It's very interesting. Another unrelated question is, a couple of my guests have suggested that we may not actually understand the structure of the atom. Do you have any thoughts on that and whether our current understanding is correct of the atom?
We once thought that the atom was the smallest particle on planet Earth. And then we found that there were subatomic particles in the atom. And we had to change our thinking. We then found that these subatomic particles, like electrons and protons and neutrons, etc., were composed of smaller subatomic particles. So we then had to change our thinking again. And for me, there's no reason why we could find subatomic particles. It just depends upon the equipment we use. We're continuing to invent new and more sophisticated equipment. Understanding the atom is absolutely vital to understanding physics. And I think that's, again, another open book for people to study in the future. I think it's quite fascinating. We think we understand a lot of things, but the more you know, the less you understand. And the more you know, the less you're dogmatic about things. And that's why I argue that our climate scientists are mathematical modelers. They're not polymaths. They don't know very much in other fields. And therefore they use statements such as the science is settled. To me, that demonstrates they know very, very little indeed. Science is never settled. And your viewer's question is saying that science is not settled. Can we actually find subatomic particles? The answer is probably yes.
Do you have any hope that academia is going to become less woke and we won't have so many people working on woke science and more people working on hard, real science?
Universities were created in the medieval warming, because there was so much money around, to train young men for the priesthood. These were vocational organisations, and it was for training men for the priesthood. Later, universities dealt with other vocations, such as medicine, and even later, they dealt with other vocations, such as engineering and the other sciences. And even later, they then dealt with the classics, and that was to use the philosophers and classical writers of the past to get an understanding of civilization and get an understanding of the present. In the last 50 years, universities have expanded in number, they've expanded in staff, they've expanded in the offerings of courses. And so you can get courses now in left-handed gender bending, and that can be regarded as a valid discipline. And so I think the solution for the future is to reduce the number of universities, to have university entry based on national or examinations, and to have some courses just not taught. I can't see why we should be teaching courses in certain forms of propaganda. And we should be training people, as universities were originally set up to do, we should be training people to actually add value to society. Now, that value could be cultural through studies of classics, or that value could be through science, engineering, medicine, vet, etc. But I think the universities have completely lost their way. Most of them are funded by the taxpayer, and the taxpayer should be saying, no, we're not getting value for money. Once universities start to teach law, which was a couple of centuries ago, then they started to expand into areas where opinion rather than data becomes important. And I think the structural breakdown of universities goes back a long way, but the rapid breakdown is 50 or 70 years old. And that started, I think, with the student riots of 1968 in Paris. That led to a breakdown of the way in which universities operate. And I think now, in many parts of the world, if you have a pulse, you can go to university and get a degree. In my view, universities are for the top 1 or 2%. These are the elite. We're not allowed to use words like elite now, but the elite are those who've got the intellectual capability of going to university. Most of the people, and this has been my experience of teaching in universities, most of those in university don't have the ability to be at a university.
Okay, we're coming up to the end of our hour here. Any other points you'd like to make before we finish up?
Yeah, we've been all over the place, haven't we?
We have.
A bit like this book, it's all over the place.
Exactly. Yep.
It talks about, in the book, I talk about all sorts of things, a few amusing stories, like one called The Environmental Impact of Creation. And I was looking at God creating the heavens and the earth, and how immediately when God started the creative process, he was served with an injunction by Greenpeace to stop the creative process. And I go through creation and point out that under today's environmental laws, it would not be possible. There are a few light-hearted essays in that book as well.
Yeah, another one that I enjoyed is your ideas for hosting COP31. You had some great ideas there.
Oh, yes. Well, I picked a pretty isolated, dreadful area of Australia to have COP31 and have it on a clay pan in the middle of the bush. I mentioned one Australian politician who can talk for about 10 hours without taking breath, and is boring as anything. But just basically to let people know how the real world operates, rather than having people flying in their private jets and have a wonderful gab fest and then tell everyone else how they should live their life. So it was putting them in the outback of Australia and holding a COP festival there, and that would sort them out. And very few of them would have survived it, so that would have been a good thing also.
Yeah, it's said as a joke, but I think that would be way more valuable than all the other COPs put together, for sure, if you actually did that. Okay, I will let you go, but thanks a ton for doing this. You're super interesting, and I love your book, Sceptical Always. I will talk to you next time.
Thank you for having me.